Hello, and welcome to another bone tutorial. So this one I'm going to cover the disarticulated spine and sacrum and coccyx. So I'm doing these at home and I don't have an articulated skeleton at home or an articulated spine. So I'll talk more specifically about those in lab. But at least I can go through the different kinds of vertebrae, the markings on the sacrum, and so the markings on the individual vertebrae. So I'm going to start there. It's going to start here, vertebral column, cervical vertebrae, and kind of move on to the next page. So there are 7 cervical vertebrae, and you need to really only be able to identify specifically the first 2. The other ones are all just going to be general cervical vertebrae. I'm not going to be asking you to identify, is this C2 and T5 and L1? You're not going to have to know that much detail. You should be able to distinguish the difference between those the 3 different types, and I will show you how to do that. But you do need to know the details of these 2 here. These are C1 and C2, your first 2 cervical vertebrae. And they have special names. So there are C1, but this is also called the atlas. So atlas is C1, and if you'll notice, it does not have a vertebral body. So it's lacking that big chunky part that all the other vertebrae have. But it is still cervical vertebrae. It has 3 holes. It's got the transverse foramen and the vertebral foramen, which we'll see kind of the names of those in a little bit. But this articulates with the occipital condyles of the occipital bone of the skull. So I'll grab my skull real quick that I have at home. So these are the occipital condyles. And so the atlas articulates just like this, okay? Oops, there we go. We can actually see it. So you're going to see the occipital condyles on either side of the foramen magnum, and then here is C1 sitting on top of that. It's the beginning of your spinal cord, or the beginning of your spine. Okay, so recognize this as C1, no body, and it's pretty thin. C2 is called the axis. And the reason why it's called the axis is because it's got this little pointy piece right here, and C1 sits on top of it like this. They stack like this. Sorry, I had it backwards, upside down. So there's how C1, C2 articulate here, and the axis allows for a tiny little bit of rotational movement between C1 and C2. Not a lot, but a little. And you can't really control it. So you can't be like, oh, I'm just turning between C1 and C2. You don't have the muscle control to do that. But there is a marking on C2 that you have to identify, and it is called the odontoid process or the dens. And it's just that little bump here, like an axis. That you have like a wheel rotates around an axis. You have the odontoid or dens. Okay, so that's C2. Then we have just a generic cervical vertebrae. And again, so some of the features of cervical vertebrae is they're the smallest of the 3 types. So I'll lay them out here so you can see cervical vertebrae are the most delicate. They're the ones up here, 7 cervical vertebrae. If you'll look at their vertebral foramen, which is the hole in the middle, it's kind of triangular shaped. So that's where the spinal cord travels through. So it kind of has a triangle shape to it. And all cervical vertebrae have 3 holes, your vertebral foramen and your 2 transverse foramen. And the hole here in this is just for the model. They ran wires and stuff through it. So ignore those. Those are not real holes in the bodies of your cervical vertebrae. So you have 7 total cervical vertebrae. Oh, the last one, there is on the list here, this guy here, the vertebra prominens. I'll have to show that to you on a articulated spine. It's C7, and you can actually feel it if you run your hand down the back of your neck, and that first bump that kind of happens like right here, that is the spinous process of vertebra prominens. It marks the end of the cervical vertebrae and the beginning of the thoracic vertebrae, kind of at that boundary. So then your thoracic vertebrae here, if you'll notice, ignore these drill holes in the body. You also have vertebral foramen, but look at its shape. It's very round, almost a perfect circle. So we can see that the transition between cervical vertebrae with a triangular vertebral foramen changes to a circular vertebral foramen. Okay? And it's kind of medium sized, but what if you didn't have any other vertebrae around? How would you tell if you didn't have anybody to compare to? Well, I would say look at the posterior surface and tell me what animal that looks like. This is a giraffe. So if you are unsure, just look at its face, if you will, but it's the back side of it. And this is your little giraffe. And then the last one is our lumbar vertebrae. These are the biggest. So get those out of the way. Again, here's our 3 vertebrae. We can see the lumbar are the most bulky. They're down towards the base of your spine. They can have to withstand a lot more weight and compression day after day, step after step. So they have a nice big body. And then again, take a look at that vertebral foramen. It's gone back to triangular shape, okay? So we go triangle shape, circle, triangle shape for those vertebral foramen as we go from cervical to thoracic to lumbar. And then again, if you didn't have anybody of its friends, what animal does that look like? It kind of looks like a moose. It's not as moosey as the thoracic is giraffe, but it kind of resembles a moose. So we have moose, we have giraffe, and we have the tiny little 3 holes, 1, 2, 3. So that's how you can tell the difference between thoracic, cervical, thoracic, and lumbar vertebrae, and then the details of C1 and C2. Okay. Next, moving down on the list, I'm going to talk about the sacrum. So we'll go over the parts of the sacrum and the coccyx. Set those aside because I'm going to bring those back. So this is your sacrum. The sacrum is made up of 5 fused vertebrae. So they probably started off as individual bones in utero, but then as you develop into a more mature being, they fuse. So we can see the bodies, 1, 2, 3, 4, 5. So there were 5 individual vertebrae, but it's now all fused into one bone. So the first marking on the list is called the ala or alae. It is these wing-like kind of smooth structures right here on either side of this flat articular surface here. So these are the ala. And then we have the holes. So these are just all called sacral foramina. Foramina is plural for foramen. So anterior, posterior holes, but it's all the same hole. So sacral foramen for one, foramina for plural. And then we have the sacral canal. It's not shown here. Again, I'll show you more in lab. We have a good real sacrum bone that shows that, but there would normally be a hole here where the spinal nerves would continue to go through. That would be the sacral canal running underneath the spines here. And then the hiatus, again, imagine that there would be an opening here. So the canal starts here, hiatus ends down here. And right here, this is called the median sacral crest that runs over top that canal that ends in the hiatus. And then lastly, this kind of sticky out part, if you look horizontally, here's my vocabulary, the sticky out part. This is called the promontory. Think, because it's prominent. It's prominently pointing anteriorly. Okay, so that's your sacral promontory. All right, so those are all the parts and pieces of the sacrum. And then we have the coccyx, which is anywhere from 3 to 5 fused vertebrae. So it is one bone, but it can vary. It averages 4, right? 3 to 5. So this one has 1, 2, 3, 4, tiny little one down there. So this has 4 fused vertebrae, and you just need to know this as the coccyx. There's no markings on that one. Okay. So I will show, I don't have an articulated pelvic girdle here, so I'll talk more about that in class. But you'll see the articulated pelvic girdle with the 2 coxa articulated with this. I'll talk about that in lab. Right? So that is your sacrum and the coccyx. The next part of the list I'm going to go over will be all the parts of the vertebrae. And with the exception of the transverse foramen, you'll be able to see all of these parts on every single vertebra, except for the intervertebral disc. You have to see that on an articulated spine. Spine. Yes, so body. So we can get C1 and C2 out because they don't really follow along. So I'll try to point out each one of these markings on each of the vertebrae. So body, 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 okay? vertebral foramen or spinal foramen. Vertebral foramen is the hole where the spinal cord goes through. We identified that earlier as a triangle, circle, triangle. And then we have our spinous process. So that's the sticky out, another sticky out part here. And it's going to be the noses on our giraffe and our moose. So this is the most posterior marking of the bones. Kind of makes up the bump so you can run your fingers down your spine. So these are the spinous processes. And then we have the transverse. So transverse kind of means off to the side. So for the cervical, it's a little bit more challenging because it's not quite as obvious, but this little guy right here will be the transverse process. So I'm going to hold the bone via the transverse processes. Okay, so I'm holding those. For the giraffe here, it's more obvious. It's their little horns or their ears, whatever those parts are. Okay, transverse are sticking off way easily out to the side, easily identifiable on the thoracic. And then on our moose, it's these parts right here. So we can kind of see that it's sticking off to the side, transverse, transverse. Okay, so now we have our superior and inferior articulating processes. So again, it's going to be a lot more obvious on some, a little bit more subtle on the others. And the best way to identify these is to kind of look laterally. So here is a superior articulating process. And here is the inferior articulating process. And you'll notice it's really flat because that is going to articulate with the bone above it and the bone below it. So your superior and inferior articulating processes have articular surfaces that will match up with the bone above or below. So these are the superior processes, and these are the inferior. Okay? So they're really small and reduced on the cervical vertebrae. On the thoracic, the superior processes are really obvious. It's these little guys here. On the backside, it's not quite as obvious. It's like the jowls of our giraffe right here. So if we look on that transverse view or that lateral view, so here's our superior process, and here's the inferior process. And then the lateral is kind of sticking out right in between the two. On the lumbar, probably the most obvious, these are the superior articulating processes, and these are the inferior articulating processes, right? So again, if we look at a lateral view, superior, inferior. Okay. And then the next one is called the intervertebral foramina. Let me see if I can grab another one. Here. So these ones, again, you need an articulated spine. I'll try to do the best I can here, but you don't really see those until you stack some bones. Uh-oh, my camera froze. Let's try share screen again. We'll see if we can get this technology back working. There we go. Okay, cool. So you don't see an actual foramina, a hole that's the intervertebral foramina on an individual bone. So you have to stack them, and then you can see the opening right here. So in lab, we can really see that very well on an articulated spine, and you'll actually see little yellow, rubbery nerves sticking out. That's where, so your spinal cord runs down the holes, and the spinal nerve will branch off at every level. So when you articulate them or stack them, if you will, that's when you're going to be able to see the intervertebral foramina. And then lastly, the intervertebral disc would be like the cartilage disc that sits in between and keeps those bones from touching each other. And again, you'll see that in lab on the articulated spine. And then lastly, that transverse foramina is only going to be on the cervical vertebrae. We've identified that and mentioned that a couple times already. Okay. So that wraps up the discussion on the vertebra, and I will see you for another video. Bye.